we are going to learn a problem from subject automata theory and computability, whose course code is 21CS51. So basically the problem is from the conversion from NFA to DFA. Moving to the problem, before moving to the problem, let's know what is NFA and DFA. So NFA is nothing but it stands for non-deterministic finite automata, which is easy to construct NFA then DFA with the regular language. So the finite automata are called NFA, where there exist many paths for the specific input from the current state to the next state. So every NFA is not DFA because each NFA can be translated into DFA, but it is not DFA. DFA refers to deterministic finite automata. Deterministic refers to the uniqueness of the computation. The finite automata are called deterministic finite automata if the machine is read an input string one symbol at a time. So in DFA, there is only one path for specific input from the current state to the next state. DFA does not accept the null move. The DFA cannot change state without the character. So here is the first problem. We are going to see the problem is going to solve with the respective diagram. So the diagram is of non-deterministic finite automata. It is nothing but NFA. So first, we are going to draw a transition table where we are going to have three states with two inputs 0 and 1. You can see in the diagram there is three different states Q0, Q1 and Q2. So with respective two inputs 0 and 1. So 0 and 1 we are going to see where the inputs are moving which with the current state to the next state we can see we will see and we are going to put it in the table. So basically what we are going to do is Q0 is a state in the diagram. You can see this is a state. Q0 is the initial state, and this arrow is nothing but the start state. The Q0 is the start state, and these the second the two circle we can say it is a final state. So it is called as final. The circle which the any state which has two circles or two rounds of like this, it is nothing but the final state, and the arrow which is here you can see it is it shows as a start state. For the start state these arrows are written, and for the final state these are drawn with two circles. Hope you are understanding. So here we can see there are the three states. So starting with the initial state Q0, we are going to see with respective two different inputs where it is moving, where it is going from the current to the next state. We'll see. So basically we have three different columns: start, 0 and 1. So Q0 is the initial state. We are going to see with respect to 0 where it is going. You can see Q0 with respect to 0 it is moving to itself. So we are going to write is at Q0. Q0 with respect to 1 it is moving to Q0 with respect to 1 it is moving to Q1, and also you can see there is one more row arrow which is moving to Q2. So basically we have two different states. The one is moving to two different states. So we are going to write Q1 and Q2 in this box. With respect to 1 we are going to write Q0 with respect to 1 moving to Q1 and Q2 because it is moving to two different states. So Q2 with respect to 0 I'm sorry, Q1. Q1 with respect to 0, see, you can see there are two arrows. One is moving for itself and one more is moving to the next state, that is Q2. So basically, we are going to write Q1 and Q2. In the column of 0, Q1 with string 0 moving to Q1 and Q2. Q1 with the string 1, where it is moving, there is only one 1. There is only one 1 moving to Q2. It is written here. Q1 with the string 1, it is going to Q2. Q2 with respect to 1, you can see Q2 is moving to two different Q2 with respect to input with the respective 0 input moving to two different state Q0 and Q1. Same way I have written here. And Q2 with respect to 1 where it is moving only one state, that is Q1. So we have written the first transition table should consist of the current states. What are the current states in the diagram? Those are Q0, Q2, sorry, Q1, Q2. So in this thing, I'll tell you, we have written all these strings moving to current state to the next state, as you have seen here, how I've explained you. So same way, we got here some different states. You can see Q1, Q2, Q0, Q1. Here you can see Q1, Q2. These are not our states in the diagram, right? We have only three different states, Q0, Q1 and Q2, but we don't have Q1 and Q2. So these are our new states. New states. So new states are nothing but we are going to solve for this also. We are going to have a transition table for this also. How? Let's see. Here I have written in the steps, step number 1 with del, this is the transition symbol. So with Q0, with respect to Q0, 0, we got Q0, as you can see in the table, what I have written the previous side. Then Q0 with respect to 1, we got Q1 and Q2. As we don't have Q1 and Q2 in the diagram, I am repeating, as we don't have Q1 and Q2 in the diagram as a state, so we will consider it as a new state. New state. So Q step number 2, same thing, we are going to see Q1 with respect to 0 and respect to 1. We have written in the column. With respect to 0, we got Q1 and Q2, and with respect to Q1 with respect to 1, we got Q2. Same thing I have written here. So these are the steps how you're going to do is. So as we have two repeating states, new states, but two repeating states. Q1 and Q2 are the two repeated states, but we will consider only one. So the starting one we have considered as a new state. So second we are not going to consider as a new state, as previously we have considered it as a new state. So in the step 3, Q2 with respect to 0, what we got is Q0 and Q1. Q2 with respect to 1, what we have got is Q1. So here we have gone with different state. So what are the different states? I have told you, like Q1 and Q2 and Q0 and Q1. So we have two different states. As we have written the steps for the three particularly current states Q0 and Q1 and Q2, for basically this thing also, this new state also, we have to going to write the steps. So let's see. See in the step 4, what I have written is Q1 and Q2, as I said, that is the new state. So with respect to 0, how I have written in this? This is a little bit change in this. Like we have two different states. As we don't have this in the diagram, the Q1 and Q2 is not in the diagram. So how we are going to solve this? See, specifically we are going to take a single states as Q1 with respect to 0, Q2 with respect to 0. And we are going to have a union symbol. It's nothing but it's going to combine the state. So what we're going to do is Q1 with respect to 0 union Q2 with respect to 0. We can see Q1 with respect to 0, what we got Q1 and Q2, as same thing we have to write here, union Q2 with respect to 0, what we got Q0 and Q1, same thing. How we are going to get this Q0, Q1 by Q1 and Q2? Simple thing. We have Q1, two repeated states here. We are going to take it as one only. So first going to have the smallest state Q0, then the Q1, then the Q2, and this thing is not in the table. Same way, what I have told you in the previous slide, we are going to consider this as a new state. Now this is our new state. We are going to solve a step with this also. So what is a new state is Q0, Q1 and Q2. We are going to put this in the transition table. I'm going to draw, I have already drawn a table, transition table 2, where I have written this thing. So same thing with respect to 0 we have done, we will do with respect to 1. What is there? Q1 we have written with respect to 1 union, Q2 with respect to 1. What we got? Q1 with respect to 1. We got Q2 with respect to 1. We got Q1. So both are single states and both are not repeated states. So we are going to write it as Q1 and Q2. Simple thing. So moving with the next, what we have is step 5. So step 5, what we are doing is previously we got two different states. What are those? I've shown you in this transition table. See, Q1 and Q2, Q0 and Q1. So we are going to we have to going to solve with Q0 and Q1 with step 5. So Q0 with respect to 0, we got Q0. Union with Q1 with respect to 0, we got Q1 and Q2. You can see the transition table and you can get to know how to write. It is simple. You can see in the transition table and you can write. So we got here Q0, Q1 and Q2. See, this thing is Q0 and Q1 and Q2 already have considered it as a new state. So there is no like we are not going to repeat this state as a new state. We will not consider it as a new state. We have already considered it. Same in this step 4, we got Q1 and Q2. These were our previous new states. So it is repeating one more time. We are not going to consider it as a new state as we have considered it already. So what is our new state here? Only Q0, Q1 and Q2. Even if it is repeating, we are not taking it as a new state. It is already a new state. In the previous step, the first when we got it as a new state. Now, with respect to one, what we got is Q1 and Q2. So Q1 and Q2 is already considered a new state. So it is not like we are not going to consider it one more time. So here we got a new state. What was that? Q0, Q1 and Q2. See, Q0, Q1 and Q2. We are going to solve with. We are going to solve this also in the step 6. With respect to 0, we have 3 different states. For the 3 different states, we are going to put 3 different, like 2 different, like for particularly we are going to have a union here. So Q0 with respect to 0, union Q1 with respect to 0, union with Q2 respective with 0. What we got is simple thing. See, Q0 with respect to 0. What we got? Q0. As you have remembered in the last diagram, we have this self loop. So we got here Q0. Same way Q1, Q2, Q0, Q1. You can see in the transition table and you can easily write this Q0, Q1 and Q2. So these are the already repeated states. So we are not considering it as a new state because already we have considered it. So it is not a new state. So what is in with respect to 1, what we got is Q1 and Q2. So same thing. In the transition table, what we are going to do is see, I have written in the Q0, Q1 and Q2 because those were the current states in the diagram. In the NFA diagram, what I have got is current state Q0, Q1 and Q2. I have solved, as you know, in the first starting diagram, I told you how we need to write this. Same way, how you have solved in the steps. What you got for the Q0, Q1 with respect to 0 and with respect to 1, same thing you have to write in the table. Just adding with the new states. So the final DFA, this is a transition diagram from NFA to DFA. So final DFA we have is Q0 moving, the 0 is moving to self and 1 is moving to Q1 and Q2. Q2 moving with respect to 0 input, it is moving to Q0 and Q1. And with respect to 1 input, it is moving to Q1. Q1 with respect to 1, it is moving to Q2. And with respect to 0, it is moving to Q1 and Q2. So here in Q0 and Q1, we are with respect to 1, it is moving to Q1 and Q2, and with respect to 0, it is moving to Q0, Q1 and Q2. Same by Q1 and Q2, with respect to 0, it's moving to Q0, Q1 and Q2, and you can see with respect to 1, it is moving self loop. It is a self loop. So with Q0, Q1 and Q2, the 0 is self loop. It is self itself, and 1 is moving to Q1 and Q2. So you can maybe you remembered I told you the double circle is to those which is the final state. And in the previous diagram, we had a double circle for what? Q2. So in this, wherever the Q2 is there, we need to have double circle here. So we were having for the final state was a Q2. And in this, you can see Q2 is also present. So we are going to have a double circle for that. And here, same way. Okay, and this thing is in this transition diagram, you can write the state and you can organize by yourself. It is it is not a mandatory that you need to write as Q0, Q1, Q2 or anything. You can have your desired desired organization. You can do anything. You can put these states anywhere as you like. There's no problem in that. Just you have to write those inputs according to the transition table. That's it. Okay, hope you like my video. Thank you so much. And please like and subscribe my channel. Thank you.